Today we're going to talk about a typical valve system. So it's going to consist of a monitor, a joystick, the joystick interface box, and then a valve. We've got a couple different models. We've got a standard gateable, which as you slide the slider, it's going to adjust the gate, how far open it is, or we've got a basic on-off valve. So the first thing you're going to do is isolate the monitor to make sure the monitor is working properly. You can do that two ways. You can either turn off the master power switch, or you can get the power incoming to the monitor right here. It's the red and black 14 gauge wire. It's a simple pinch plug. So you disconnect that, make sure the power light goes off, and you're good to go. The next step would be to disconnect the communication lines. Again, it's just a pinch and pull type terminal. At that point, the monitor is isolated from the entire system. So now go ahead and put your power back in, wait for your power light to come on steady. At this point, test operation. Make sure you have horizontal, vertical, and your nozzle functions, and then you know that the monitor is good. All right, once we confirm the monitor is working properly, we're gonna go ahead and disconnect power again. Plug in your communication lines and plug power in one more time. So the blue and white communication lines is the color wires we use throughout the system. You will find from time to time green and white. That's just a vendor purchased cable, but it matches up green to blue, white to white. Another thing you can check while you've got this open is make sure that all the LEDs are flashing. That's a good sign. A quick overview of the interface box. One thing you'll notice is each port is labeled on the front above the cable. So you've got your optional control, valve control, power, display, which is optional, monitor, and this would be your joystick or your tether controller. You can plug that in. So if you take a look inside the box, you're gonna see a bunch of wires. Over here is your terminal blocks. You've got your white and your blue for your communications. So again, white wires go to white wires. The blue is both blue and green, which you can see an incoming green wire right there. Your black is gonna be for your truck ground or chassis ground, and red is gonna be for your power, which can be 12 or 24 volts. From here, we feed power over to the circuit board, along with communication lines come over to the circuit board. This connector right here is for your valve control. On the board, it is labeled valve 1 and valve 2. Here you've got user relays that you can use for different functions. You could tie it to a light or a solenoid or whatever you want. Up in this corner is a bank of dip switches for different configurations. In this particular case, we've got the white, blue, and gray wires. That is for a gateable valve. That's your potentiometer feedback. This green plug right here is blue and white, which again is your communication. And it's actually labeled on the board as well, blue, white, blue, white. Here is your ground for the board and your incoming power for the board. And you'll see we've got this purple wire, it's not used. So with regards to these two relays, you're gonna see etched on the board different settings for switch 1 and switch 2, which corresponds to the two switches beside the relays. You can set it for aux1 operation or aux2 operation, and also momentary and latching. So the configuration of the relays is done with these two dip switches, and your guide is right here. All right, so once again, get the communication lines that run from here to the monitor. The magic number as far as DC voltage when working with our communication lines, the RS485, is 3.2 volts. So if you measure from ground or your black terminal to either the white or the blue communication line, the magic number is 3.2 volts, which you can see on the meter. Now that voltage can vary. It might be 3 volts or 3.3 or 3.4, which is perfectly acceptable. What we're looking for is a voltage that's closer to 0 volts, like 0.6 volts or something like that. So for instance, let's say we're measuring from ground to our blue and it's 3.2. Then we measure from ground to our white and it's 0 volts. The problem could be either local to the board or somewhere else on the system. So at this point, we need to isolate this board similar to what we did with the monitor to try to make that determination. So the first thing you're going to want to do is turn off power. You can confirm power is off once that light goes out. So on your valve output, you notice you have a black and red wire, which is typically ground and your voltage. That's not the case. This is just the wires we use to output to the valve. So one thing you'll notice with power on, you're always going to be driving voltage either positive or negative. So if you put your multimeter across the leads, you'll see in this case, I've got negative 13 volts. So you'll notice once you actuate the valve, the voltage actually reverses. It is possible to have voltage driving in one direction and not the other. And typically what that would mean would be, let's say you measure it and you've got negative 13 volts when you're measuring it, and you hit the button and it drops to 0 volts. That's going to point to an issue with the board.